Good afternoon and welcome to my presentation on a comparison between Apache and Nginx web servers. Brief introduction, my name is Austin Mascarenas. This is for the Linux Unix Administration class, section W01 for the fall semester 2019 at Kennesaw State University. This presentation contains my objectives, an analysis on the Apache web server and the Nginx web server, a comparison between the two, the conclusions that I reached both from my research and personal experience, and the references that I used in my research. So my objectives for this project are to define what Apache and Nginx are, and then evaluate the two based on the following criteria: the support for each system, their security, flexibility, architecture, the modules that are available for each one, the performance that I've experienced and what I find online, and my personal experience when using both. And then I will go through my final analysis of which one I found to be the superior web server. So first, what are Apache and Nginx? Apache is an open source cross-platform HTTP web server, also known as Apache or HTTPD. It primarily runs on Linux and powers approximately 46% of all websites worldwide. It is managed and developed by the Apache Software Foundation, which is an online community that develops and supports the web server. Nginx is pronounced Nginx. It is a high-performance software used for web serving, reverse proxying, caching, load balancing, and media streaming. It acts as a load balancer and HTTP cache. It is created by Nginx, which is the company that shares the same name as the web server, and is supported by them as well. And you can find it online at their website. All right, first up is Apache. Apache has a lot of community support from the following sources. You can find support via their mailing lists, IRC, which is Internet Relay Chat, from the website Stack Overflow, or from third-party companies such as OpenLogic. They are also supported on Unix-like systems and Microsoft Windows, so you can use them on either operating system and on most Linux-like systems, like on most Unix-like systems like Linux, BSD, and others. There's plenty of online documentation for both if you need any troubleshooting done, both first and third-party support for that documentation. A lot of it is done by the online community and from the Apache software community as well. For security, Apache takes steps to ensure the websites run on its servers are secure. It has regular security updates, which is pretty standard for most applications these days. It has configuration tips to help users configure their Apache servers to meet their needs and to maintain a level of security to make sure that their websites are secure. It has configuration tips to handle DDoS attacks and vulnerability reporting to make sure that its systems stay up to date via communication between all of its users so that they know of any vulnerabilities that anyone in the community might find. They also have additional modules to help security issues such as Mod Evasive, which is a module designed to increase security on Apache servers. In terms of flexibility, Apache has a number of different means to customize the server that you're using. There are different modules that can be added to Apache and a large online library of downloadable modules that can be dynamically loaded to each server configuration in order to suit the individual needs of their users. They have community sites as well that support different configurations that you can download directly, and there are modules that can be written by the user themselves if you're savvy enough to do that. In terms of architecture, Apache uses the process-driven approach. It employs multi-processing modules to handle requests on the server and creates a new thread for each request. As a new user comes in and creates a new request, a new thread is created per user, which can lead to heavy resource consumption and low efficiency when there's a large number of users on an Apache server. So it's not really good at handling large numbers of users on each of its servers. The main types of NPMs that it employs are the process thread, the worker thread, and the event thread. So in terms of modules and module support for Apache, Apache's capabilities are extensible through the module system. There are over 60 official dynamically loadable modules that can be turned on and off whenever you load up your server. This allows Apache to meet a variety of different requirements depending on what the user downloads and how they want to set up their servers. And these modules can be easily swapped out based on content requirements. So In terms of flexibility, Apache has the edge over Nginx here, and I'll get more into that later on in the presentation. So in terms of performance, we have to discuss both static content and dynamic content when talking about web servers. Static content is any content that can be delivered to an end user without being generated, modified, or processed. Apache uses a conventional file-based method, and performance of static content delivery is a primary function of the NPM methods. So it does static content fairly well on its servers. For dynamic content, which is web content that changes based on the behavior, preferences, and interests of the user, it can process dynamic content without relying on external components using dynamic processors embedded into the worker instances. Communications do not need to be coordinated with additional software. This means that Apache can handle dynamic content completely in-house and does not need anything additional added onto it in order to handle or process and send out dynamic content. So for installation, Apache is pretty easy. All you have to do is download the files off the website. I was using a Windows installation, and I followed the instructions that it had for me, using the command httpd-k to install it onto my system. And there's plenty of online support for any other operating systems. So there's instructions for each operating system, how to install Apache onto your computer. After you complete the instructions, just open up a new browser in your open up a new page in your web browser and enter either your IP address or HTTP localhost, and then it'll pull up the image you see on the right at the top showing that it works. And then you can use on Windows either the command netstart or netstop in order to activate or deactivate the Apache web server. So for the modules and configuration for Apache web server, module installation is pretty easy to download. There's plenty of websites out there, both the Apache website and a lot of websites made by the community where you can download individual modules and install them onto your web server. It is a little bit difficult to figure out how to configure and use them on your own. So there's a lot of instructions out there on how to perform these actions and get the modules running on your web server, but they're a little bit technical and not too difficult, but they are a little bit difficult to use if you don't know what you're doing. They are all perfectly readily available though, and there are different pre-packaged versions like XAMPP, seen here on the right at the bottom, where it comes with a lot of different modules already preloaded and a user interface in order to start and stop each individual module or system or however you want to do it. So I recommend one of the pre-packaged versions to new users because it's just easier. The configuration, you'll have to configure your Windows firewall depending on the settings of your firewall in order to make sure that it doesn't block your Apache web server. So for lessons learned and errors, most of the errors that I encountered during my installation and running of the Apache web server were primarily syntax errors or human error on my part. Being a new user and being brand new to the system, it can be a little bit difficult to get down all the different commands that you have to enter in, and I'm bad at typing. There were a little bit of difficulties with configuration on my own, but then again, I switched to the community created pre-packaged systems, and that was a lot easier to work with. I got some good experience with Apache from this, and something that I've never worked with before, and it was a new experience altogether. And I learned that I'm the type of person that really needs to use packaged services and prepackaged stuff, because figuring out things on my own takes just a little bit too much time that I didn't have to work on this project. All right, next up we'll go through Nginx. So support for Nginx is managed by the Nginx company instead of an online community like Apache. The support resources can be found at the Nginx website, through their mailing lists that you can sign up for at their website, through IRC, just like Apache, through different community forums, mostly managed on their website, but are also managed on Stack Overflow and other websites like that, and through third-party documentation that you can find via Google or any other search engine, just looking for support for Nginx. Nginx has a couple of different options to keep websites running on its servers secure. Just like Apache, it has regular security updates, different configuration tips based on what you're using your web server for, vulnerability reporting, similar to Apache and like most other services you'll find today. And it has a smaller code base, however, than Apache, which gives it a slight edge in security, but it doesn't have anything unique to it that makes it more secure than Apache. In terms of flexibility, Nginx also has a number of different options available to use for customization. There are modules that can be added to Nginx. It has a smaller online library. It's been around a lot for less time than Apache and has a lot less widespread support than Apache does. So the amount of modules available is significantly less than what Apache has currently. These modules also can't be dynamically loaded, and it has to be compiled within the core software, which gives it fewer options for customization and fewer options for each user, as if you want to, say, create your own module, you're not quite capable of doing that as you are with Apache. So the Nginx server uses the event-driven approach to handle multiple users on its servers. It handles multiple requests with one thread. A single thread is used for several different users instead of a new thread per user. This makes it much more efficient at handling its resources, and each worker process can handle thousands of connections instead of one process per connection at a time. Worker processes work in an event loop, so each process will activate in a loop and then roll through the loop when they're needed. So they're only active when they need to be, when the user is actually active on the server. This increases scalability for the server and it allows it to maintain consistent efficiency, operational capacity while under heavy load. And it can use almost the same amount of resources throughout any stress level, throughout any load that's put onto the server. Nginx capabilities can be extended just like Apache through modules. It has official modules and third-party modules that are available online. They are, as I said before, fewer in number than Apache, and they fulfill useful requirements without sacrificing performance. They cannot, however, be dynamically loaded, and the only difference between the support for modules on Nginx and Apache is the amount of them. Apache can do basically the same things that or Nginx can do basically the same things that Apache can do and has modules that do similar things or the exact same thing as Apache, but there are just fewer number of them and less availability for Nginx. In terms of performance, for static content, the event-driven approach works faster than Apache for static content, approximately 2.5 times faster while running 1,000 concurrent connections, which consumes less memory per user. The dynamic content, Nginx has no ability to process dynamic content without external support. It must pass dynamic content to an external processor for support. This results in less efficient processing of dynamic content than static content. So Apache and Nginx process dynamic content about the same. However, Nginx requires an outside source to do so, whereas Apache does not. To install Nginx, I was running it on Windows, again, just like Apache. All you have to do is download and extract the information, or extract the files from the Nginx website. It's pretty easy to execute, and there are plenty of links for support both on the website and again on some community sites as well. Once installed, all you have to do is type in localhost in a new browser, in a new window, or your IP address, and it'll bring up the image that you see here. It comes in pre-built packages or can be compiled from the source, similar to Apache. However, for this one, it didn't require any additional commands on my part. All I had to do was download, extract, and then launch it, and it worked fine. I didn't have to enter in any additional commands, so installation was easier with Nginx than it was with Apache. So again, for the modules for Nginx, it has a significant online library, not as big as Apache, but serviceable enough. It's company supported and third-party supported, so there's modules created both by the company to meet different requirements and by third-party companies and organizations to support Nginx. You can download and compile them, but directly to your Nginx web server. So for lessons learned, I had fewer errors with Nginx, primarily because it required less input from me, and mostly problems that I had with Apache were from my own inputs. So it reduced the number of errors and made it faster to both install and get into using it that way. For lessons learned, similar to, I would probably do this again on Linux instead of a Windows operating system, since both of them were created primarily for Linux. And I would also use package services from the get-go instead of trying to download the base servers themselves and then add in modules later myself. It is time consuming to do so, and unless you have specific requirements that can't be met by any of one of the prepackaged services, I would suggest the prepackaged service is the way to go. So for part 3, comparison. So the pros and cons of Apache. The pros of Apache is that it's open source, it's highly customizable, and very flexible. It has a large online community and plenty of support. There are lots of modules and different techniques that can use and changed around to do whatever it is you need to do with an Apache server. And since it's highly flexible, it can be used for almost any environment to do almost any task. The cons, though, is that it's complex. It has a barrier to entry that requires a certain amount of time in order to make it function the way you want to, unless you use a prepackaged service. So, and it's slower in efficiency than Nginx. It doesn't have the ability to scale up to large numbers of users on the web server. Its best attribute is its flexibility, of course, though. It can be used for almost anything, for any purpose that a user can come up with. There's something there for Apache that Apache can do. Apache can handle almost any job. For pros and cons for Nginx, Nginx has high efficiency and good security. Better than Apache due to its smaller code base and restrictions on modifications, but nothing specifically that makes it shine out more than Apache. Nothing that, no single feature makes it better at security, aside from the fact that it just doesn't have that large code base that Apache does, and it hasn't been around as long, so there's less exploits for Nginx. It is highly efficient, though, and it excels at handling multiple users on websites by using system resources more effectively than Apache does. On the con side, it lacks flexibility, and by that I mean it lacks flexibility compared to Apache. It still has a fair amount of flexibility, but it can't match Apache's wide range of different modules and different uses that it can be put to work for. It has good support, both from the Nginx, and it does lack the large community backing, the large amount of support that Apache does. Apache's been around longer, and it has a large community built around it that helps support the system, and there's just less of that for Nginx. Its best attribute, of course, is its efficiency. It's just better at handling large numbers of users than Apache is. So here's a comparison chart that I put together for both servers based on the different criteria that I graded them off of. Apache and Nginx do pretty similarly in terms of support and security. Nginx comes out a little bit, but not so much so that it's necessarily better overall. In terms of flexibility and modules, the different modules that are available, Apache has Nginx. Apache wins those two categories. Nginx does better in terms of architecture and performance because it's capable of handling, it's just more efficient and handles multiple users much better than Apache does. In conclusion, there's no real clear winner in terms of capabilities of each web server. Which server a user picks is largely determined by their unique requirements. Apache has an edge in flexibility, however, Nginx is clearly much more capable at handling high volumes of traffic. Many websites use both in conjunction to suit their needs. My personal conclusion is that I like Nginx more for its usability and its organization. It was just more user-friendly to me. However, I think the two in conjunction work best. Nginx is capable for its efficiency, Apache for its flexibility, and a lot of different companies, like I said, a lot of different websites use both together, and I can understand why after doing my research. These are the references that I used during my research. And if you have any questions, please feel free to contact me at my student email address. Again, I'm Austin Mascarenas, and thank you very much for your time.